Lesson 9-1, Day 1, Graphing Quadratic Functions. Our essential question is, how do you find the vertex of a quadratic function? We have 5 new vocab words today. The first one is a quadratic function. That is a nonlinear function, so it's not a straight line. It actually has a U shape to it, and the graph is called a parabola. It's called a parabola. Standard form is our next vocab word, and this is standard form for a quadratic equation. F of x equals ax squared plus bx plus c, where a, b, and c are actually replaced with numbers. Kind of like standard form when we worked with linear equations. A, b, and c are integer values though. The axis of symmetry. The axis of symmetry in my graph is the dashed green line. The axis of symmetry splits your parabola in half, because symmetry means that it would split it so that it's got 2 equal sides. You can think of one side of that parabola being reflected over the symmetry line to match the other side. To determine where the axis of symmetry is drawn for your graph, you can use the equation x equals the opposite of b divided by 2a. Instead of saying negative b, I like to say the opposite of b, because if b happens to be a negative, when you plug it in, making it the opposite would be positive. You'll see that when we work through some examples. So the axis of symmetry is a line. It's a vertical line. That's why its equation always starts with x equals. So you plug in the values of a and b from standard form, and then you simplify it to get the axis of symmetry. To find the vertex, you may notice that the vertex point right here kind of looks like a bullseye. The vertex point is the only point on the axis of symmetry. It's the only point that's right on the axis of symmetry. To find the vertex point, you use the x coordinate from the axis of symmetry, and then you plug that value in for x in the original equation to find the y coordinate. The y-intercept is where the graph crosses the y-axis, and from looking at the equation, it's whatever letter c is. So where the graph crosses the y-axis, just like when we worked with linear equations, and if it's where the graph crosses the y-axis, x would be equal to 0, which leaves you with whatever number c is to be your y-intercept. Okay, let's try this out. Some of your homework problems are like this, where they give you a graph. So from this graph, we need to find the vertex, the axis of symmetry, and the y-intercept. So my vertex is this point right here. And looking at where my x and y axis are, here's my x-axis, and here's my y-axis. That ordered pair would be 1, 2, so 2, right, 2, and then down 3, 2, negative 3. The axis of symmetry splits that parabola in half, so the axis of symmetry is going to be the vertical line represented by x equals 2. Remember that the x coordinate of the vertex has to match the axis of symmetry. And then my y-intercept is right here, so my y-intercept is 1. That's where that quadratic, that parabola, crosses through the y-axis. Another example, like the last one. So we're looking at a graph. Here's my x-axis. Here's my y-axis. My vertex this time is at negative 1, 2, 3, positive 2. So vertex is an ordered pair, negative 3, 2. My axis of symmetry has to match the x-coordinate on the vertex splits the parabola in half, so it will be x equals -3. Remember the x equals because the axis of symmetry is a vertical line, Every point on that axis of symmetry has an x-coordinate of -3. And then last, I need the y-intercept, so on my y-axis, right here would be 7. So my y-intercept is 7. Now our next couple of examples, we will be working with an equation that's written in standard form instead of a graph. So from standard form, you need to identify A, B, and C. Remember, standard form was ax squared plus bx plus c. So the value of A in this quadratic is 3, B is 6, and C is -4. Now, I'm going to use the axis of symmetry formula. X equals the opposite of B over 2A. The opposite of B, if B is 6, would be -6. And then 2 times A, which is 3, would be 6. So if I divide these, my axis of symmetry is -1. X equals -1. To find my vertex, I take that value and I plug it in. So I know that in my vertex, -1 is my x-coordinate, but I need to solve for y, for the y-coordinate. So I'm going to take the value, x equals -1, and I'm going to plug it in where I see x in the original quadratic. -1 squared is 1. So I do my exponent first, then I can multiply from left to right, and then add or subtract. So I get -7. So -1, -7 is my vertex. And then last but not least, my y-intercept. My y-intercept, you can find 2 ways. You can plug in 0 for x and solve it. Doing this gives you -4, which happens to be C. So you can either remember that C is your y-intercept, or you can plug in 0 and solve for the y-intercept. So we have the axis of symmetry, the vertex, and the y-intercept. 3 pieces of information about our quadratic. Another example like that. On this one, I am going to put a 1 in front of my x squared because A equals 1, B is -6, and C is 7 for this problem. The axis of symmetry formula is first. X equals the opposite of B over 2A. The opposite of -6 is +6. And 2 times 1 is 2, so 6 divided by 2, x equals 3 is my axis of symmetry. For my vertex, I take that value, x equals 3, and I plug it in the original quadratic to solve for y. 3 squared is 9, minus 18 plus 7 is -2. So then my vertex is 3 from the axis of symmetry and -2 from what we just solved. There's my vertex. The y-intercept is just C, so the y-intercept is 7. And there's your 3 pieces of information. So from a graph or from an equation written in standard form, you should be able to determine the axis of symmetry, vertex, and y-intercept for your quadratic. One more example. On this one, A is -2, B is -8, and C is 1. Axis of symmetry, x equals the opposite of B, so +8, divided by 2 times A, 8 divided by -4, so x equals -2. The vertex, plug in -2, and be careful, because this one looks a little trickier when you plug it in with all of the negative signs. Make sure that you do the exponent first. A negative times a negative is a positive. And then you can do your multiplying. So -8, then +16, and +1. So my y coordinate for my vertex is 9. So -2 from the axis of symmetry, and +9 now for my vertex. And then the last thing, y-intercept is C, so it's 1. And we're done. You should be able to write a summary now. And remember, your summary was talking about explaining how you find the vertex. You could explain how from a graph, and you could explain how from an equation in standard form. And here are your homework problems.